All right, so let's talk about our internal router here. I'm going to scoot that up. All right, we're going to zoom in on the internal router here. And this is going to be lots of diagrams for a little while, sorry. So I got my internal router, and again, I'm zooming in on it. What is the internal router doing? And I want to get somewhat specific. So I'm going to put here, this is internal router. Remember, it had 4 ports, and we need to know what the 4 ports are. Okay? Last time when we did Ethernet, we plugged stuff into ports, and we knew what they were because I showed you. But with Ethernet, we're just okay with letting the switch sort of handle what's connected to it. With a router, we have to go in and say what it's connected to. Okay? So we're the ones that say, for example, there's a network over here, 172.30.19. So I had to put this here. And let's say this is wireless. Okay? And the router is connecting to that access point into port 1. You all follow me here, the hardware actually going. So I've got a cable plugged into my router, a cable runs to the access point, and now I have a wireless subnet over here. It's 172.30.19. So far so good. There's real cables here. This is real stuff. All right. In port 2, I'm going to connect this one to a switch. Okay. The switch is going to have its own ports. I don't really care now because it's just Ethernet and it'll just run magically for me, so I don't really have to worry about it. This one is 172.30.20. I'm going to put on our .x. Okay. And connected into here, I'm going to have, here is a PC that has, I'm just going to put ... This is going to end with a 121. So I got a PC there. This one has a MAC address. We're used to this stuff too. It's A1. So there's our PC. So this is the IP address is .121. The MAC address is this A1. You know I'm telling you this stuff because it's just going to get really complicated, right? So keep, make sure you're following along here. I got another PC. Here's another PC. Its IP address ends with 47, and its MAC address is B1 something. That one is plugged into the switch. And then I have a server. This server's IP address ends with a .19, and it is C1 such and such. Okay, that is also plugged into the switch. And then we need to plug this switch into the router. I think I can fit all this on one page, right? So that is this subnet. Oops. Where did my orange pen go? Oh, there it is. Oh, I don't want to use orange. I'll just leave it at that. Okay, so again, this is a subnet. Everything connected to the switch is 172.30.20.x. This might be the marketing department, right? Remember we talked about that in our VLAN thing? Here's the marketing department. So next up, we got another switch. That'll fit over here. Okay. It's also got 4 ports on it. This switch, for some reason, has a lot of servers on it. This one is .16 with a D1. You guys remember where the MAC addresses came from? Where did the MAC addresses come from?
The actual device.
They are set by the factory. Okay. So I did not have to set them. Where do the IP addresses come from? From me. Remember? I am assigned this as my network part. I get to do whatever I want with this, and so I'm the one that said, for example, that my computer in my office, well, I'm not the one that said it, someone told me, but that guy got to pick what number that was. Okay, so these numbers are assigned by a person. Okay, this router is .1, and it has F1. All right, so point number one about routing is that routers have IP addresses. Okay? A router is a device. We all know it has a MAC address, right? Otherwise we wouldn't be able to deliver frames to it. It also has an IP address. Connect that in. This subnet here is 172.30.21.x. Okay? That's connected here. And we're going to do another switch here. I'm just going to connect this one over to a router. It's going to be .2, and this one is, the MAC address is 11 dash ... Okay, so I got a router up here. This router is plugged into the switch as well. This switch is plugged into port 4, and this subnet is 172.30.22.x. Okay, so let me note again. I did this diagram before, right? I had 19, 20, 21, and 22. And so now we're focused on this internal router, and I have here 19, 20, 21, 22. Okay? This stuff is also here too. So I had my border or edge router, that's this guy. And I had my router that connected me between my site, that's this guy. Good here? That's going to work really well. So there you go. So that's our setup. Now, there's 4 ports on our router. Again, each port has an IP address and a data link layer address. So for example, this router here, whichever port I plugged that wire into, it has this IP address, 172.30.21.1, and it has this MAC address, f1. such and such. Why does it need a MAC address? I might need to send a frame to it. Okay? And it needs an IP address because it just does. Everybody needs one of those. All right? Now let's do it here. So if we talk about port 1 here, it is going to have an IP address. The IP address here is the one I assigned it. I assigned it .1. It needs to be on the subnet it's connected to. So the subnet here is actually this. Okay? The 19 subnet is this whole thing, including that port on the router. This port has an IP address on this subnet. Are we good here? Next port, port 2, is also .1. Okay, how come this port can also be .1 and that one's .1? We are on a different subnet. Should we do colors? So this subnet is here. Okay, so we're on a new subnet. This subnet also has its own. I'll use this lovely blue pin. That port on the router has to be connected into that subnet. And I guess I'll go back to orange again. Okay. And my IP addresses were, I've got them in here. Is it port 3 is, it doesn't have port 3. I don't have port 3. 2. Maybe we never use port 3, sorry. Port 4 is also .1. You notice the pattern here? Normally routers you use .1 for, or .2. Like this one's .2. Oh, that can't be .2 or .1 because that one's .1. What's that one? Maybe we'll see. Okay. We okay here then? So So the router has these 4 ports. Each of the 4 ports is connected to a different subnet. This is crazy.
But kind of a default setting, the 0.1, so that when
The point 1 is just what you set your router to. It's just kind of what you do. So if I looked at
like
this
industry
computer,
standard or whatever.
yeah, it's just what everybody does. So the router that my computer, this .36 connects to, is 212.1. And I bet if I looked on this computer, it would connect to the router of 42.1. It's just the very lowest numbers, like single digits, usually used for routers. Usually the double-digit ones end up being servers, lower double digits. But it depends on you. It's fun. You get to pick. You could pick whatever you want. If you don't want .1 for your router, you can put whatever you want, because the numbers are assigned.
So with the internal router, each port classifies a different subnet.
Hmm? Yeah, so each port on the router is a different subnet.
Are we gonna talk about, falling for the same, let's say there's 50 computers to the 20.x. Does the number do anything with precedence?
Oh, she's asking if the IP address has anything to do with precedence, and it doesn't. It's purely the address.
Just first come, first served thing?
Uh-huh, yeah, it's basically, well, that's how the switches handle it. Just remember, the frames come into the switches, and then, well, we got stuff to do here.
I also was curious on the router. That's the router.
You'll know lots about packets. Well, we'll tell you this. Okay. So packets come in. And remember, we'll talk about this in a minute. Packets are addressed. They are just like a frame where they'll have a source and a destination address. A router could care less about the source address, okay? All it cares about is the destination address. The router isn't going to learn, because in switches they learned stuff. We have to program everything that the router does, okay? So we're going to program it and sort of tell it what to do. So there's going to be a destination address on the packet. And let's just talk now about, let's say a address or a packet comes in. It's going to be hard to draw up here. Oh, I'll just draw it down here. So let's say, for example, I have a packet. It's supposed to go to .16 right here. I'll write it in blue. So packet number 1 is 172.30.21.16, okay? This packet just arrived at the internal router. It doesn't matter where it came in. Let's say it came in over here. Okay, so the packet arrives at the internal router. It's going to look at the destination address. Okay, and then it's going to go through and see where does this go. All right? One thing this router knows, by the way, is it knows which subnets it's connected to. Okay? In the act of assigning this IP address to this port, I did that. You guys good with that? Like, I went in and I said, your port number 1 is connected to this. This is the IP address it is. It now knows it's connected to this subnet, this subnet, this subnet, and this subnet. And so it's going to look at the destination address and it's going to say, okay, does that match any of these subnets? Okay, so it looks at these 3 parts and it says, okay, 172.30.21, can I recognize that anywhere? And it recognizes that it's going to this subnet, and then it will send it out this port. Okay? Are we good here? So the router looks at the frame, or looks at the packet, I'm sorry. It looks at the packet's destination address and sends it out the port that needs to go down. Now, what if it is completely off the network? Let's do a orange one. Let's say I'm going to CNN.com. You guys remember this one, right? 157.226. Oops, sorry, I did that all wrong. 157.166.226.25, okay? So it's supposed to go to cnn.com, and let's just say it comes in over here, okay? So we have a new packet coming in. Someone wants CNN's website, or yeah, main website. The router is going to look at it, and what this time it needs to do is say, I don't know where that's connected to, and so I'm going to pass it to another router. Okay? You guys remember my setup here, right? Over here, this is my ISP. And in order to get to my ISP, I need to go to this edge router. That's right here. Okay? So my edge router is this one, that's .1. And so my internal router is going to send it out this wire. It'll put it in a frame such that the switch will send it to this other router. And then this router will deal with it. Okay? It has its own connections to the outside world. Okay? In this case, it's going to send it on to the ISP and they'll deal with it. All right, are we kind of okay with this general way routers work? Okay. So again, it goes based on the destination address, and that decides which port to send it out. That also determines how it addresses the frame. Can you all see that? This first one is going to this server, .16. This server is on this subnet, and so the router will put it in a frame that is addressed to that server. We good here? What do we call that process, by the way? The packet stays the same. What happens to the frame when it comes into this router? It de-encapsulates it, right? It reads the destination address. It decides which port it needs to go out. Then it puts it in a frame with the destination address of this server. So there's still going to be, what was it coming out here? You know, this is going to have its own header. And over here, it's going to look a little different. Are we good with this? Make it all pretty like a frame, right? So remember, there's a packet in here. The packet isn't changed, but the packet is put into a new frame when it comes out here. Just the same way this one would have a new. So that might be that lovely frame there. What are my colors left? And now it's going to be in a different kind of frame. This is why they pay us the big money, by the way.